The mod. Welcome everyone to this lesson once again. So in this lesson, the objectives are that everyone must be able to calculate the mod for the grouped and the ungrouped data, and then of course to determine the mod using the histogram. Remember, we have two types of the histogram: the one for equal class width and the one for the unequal class width. Okay, let's begin. The mod. What is the mod? We define the mod as the item or the number that appears most, or just change the language a little bit, it is the number with the highest frequency. And in terms of probability, it is the number with the highest probability. Shall be seeing this under probability theorem. So in short, the mod is the number that appears most, or the one with the highest frequency. So let's have examples. We have ungrouped data here, and we're supposed to get the mod. Examples number one, we can say that we have, for example, 2, 4, 5, 6, 8, 2, 9. Calculate or determine the mod. In this case, we can see that there is one number that appears most, and that is a 2. It is appearing 2 times. So we can simply say that the mod is equal to a 2. In the case we use a frequency table, we can simply have the mark here, then the frequency. So we have the numbers as 2, 4, 5, 6, 8, and 9. And the frequency of 2 is 2, the frequency of 4 is 1, 1, 1, 1, and 1. So from this table still you can see that the 2 is having the highest frequency, and therefore the mod is equal to a 2. Another example that you can have here, example number 2, is that, for example, in case we have 1, 2, 4, 2, 1, 3, 2, 5, 1. Determine the mod. Calculate the mod. So in this case, we can see that we have two numbers that are appearing the highest. For example, we have number 1. Number 1 is appearing 1, 2, 3 times. Number 2 is appearing 1, 2, 3 times. In this case, how do we set the mod? So you can simply say that the mod is equal to 1 and a 2. In other words, we have two mods. In the case we have to use a frequency table as well, we can simply come up with the mark and then the frequency. So we have our 1, 2, 3, 4, and 5. The 1 is appearing 3 times, the 2 is appearing 3 times, the 3 is appearing once, the 4 is appearing once, and the 5 is also appearing once. So from this we can see that the 1 is appearing 3 times, 2 is appearing 3 times, and therefore the mod is a 1 or a 2. What if we have grouped data? What do we do? An example is here. In the case we have grouped data, remember that we say that in case the data has been grouped, it means that the original information has been lost. We can't re-attain that original information. So in this case, what we can do is that we're going to be using a formula. And the formula for the mod is given by the lower class boundary of the model class plus d1 over d1 plus d2, everything times the interval I, or the class width I. So in other words, we need to first of all find the class boundaries. The d1 simply means the difference between the frequency of the model class and the one before it. D2 means the difference between the model frequency of the model class and the one after it. So how did it get the model class? The model class, first of all, since we're having two types of, since we can have tables with equal class width and unequal class width, then it means that when getting the mod, we take that into account as well. So the class width, in case I begin with the class width here, from 10 to 14, what is the class width? Remember, it is a 5. So here we have 5, 5, 5, 5, 5. Now if the class width is equal, then it means that the model class or the mode lies in a region where you have the highest frequency, and in this case this is the model class. This one is the model class here. So meaning that its lower class boundary will be equal to 14.5. Remember how we get to that? 14.5. The upper class boundary will be equal to 19.5. The frequency before that of the model class is this. So the difference between these two, our D1 will be equal to 28 minus 8, which gives us 20. And then our D2, which is the difference between the frequency of the model class and the one after it, we use these two values here. So this will be equal to 28 minus 27, which is equal to a 1. So let's begin. The mode is got from L1, which L1 is equal to 14.5 plus the D1 is 20. The answer that you get is the mode. So the mode is 19.26 minutes. That is how we get the mode. Now this is when we have equal class width. That is when we determine the model class using the highest frequency. How about if it is for the unequal class width? What do we do? But before we go to that, let's first of all look at how to get the mode using the histogram. We looked at this before. Assuming that we have plotted our histogram like this. How do we get the mode? You simply get the bar with the highest frequency or the tallest bar. Simply get the tallest bar, then make a mark at this point here, make a mark at this point here, at this point here, join the two using a ruler. Then do the same for the other corner and this other corner here, join the two, and then afterwards you draw a dotted line up to this point here where it points. This value here, you read it from the graph. That value there gives us the mode. That's how we do get it. So we have this example number 2. It is saying that the table below gives the distribution of interest paid by 460 investors in a given year, and we are supposed to find the model interest. We're supposed to find the mode. So our mode is given by a formula L1 plus D1 over D1 plus D2 times the interval I. And remember that in the case of being given data or a frequency table where you have the classes of different width, then when you're determining the model class, we always use the frequency density in case we have different class width. So when you're looking at the frequency tables, we see that in case of being given data like this, it means that these ones are lower class boundaries. The lower class boundaries. So from 25 we go to 30, here we go to 40, here we go to 60, here we go to 80, here we go to 110, and here there is nothing because that is like the upper limit of this data here. So the class width or the class interval is 25, 30 minus 25 we get 5, 40 minus 30 we get 10, here we get 20, here we get 20, and then here we get 30. Upper class boundary minus the lower class boundary. And we see that the class width is non-uniform. So if it is non-uniform, then the model class is obtained by getting the frequency densities first. And how to get the frequency density? Do you remember? Frequency density is simply equal to frequency out of the interval. It is just like the population density, the population number divided by the area. So in this case, I'll create another column, frequency density. 17 divided by 5, I'll get 3.4. Here 5.5. 142 divided by 20, I'll get 7.1, 7.6, this is 6.5, Here I'll get 3.1. So our model class, therefore, our model class is going to be this one here. This is our model class. Why is it our model class? It is because it is having the highest frequency density. We are using the frequency density, we're not using frequency. Sometimes it may coincide, like in this example here, that the highest frequency is coinciding with the highest frequency density. But just take it that whenever you have a class width which is different, then we use frequency density. So our mod therefore will simply be equal to the locus boundary, which is 60, plus d1. d1 is the difference between these two, difference between the frequency of the model class and the class before it. So get the difference between these two. 153 minus 142, we shall get 11. So plus 11 out of 11 plus our d2 is the difference between the frequency of the model class and the one after it. So 153 minus 93, I'll get 60. And the class interval is 20. So times 20. So this will give us our answer as, shall get our answer as 63.1 pounds. So this is our answer. So that is how we do get it. Likewise, in case you've been given the, if you've drawn a histogram, we do the same thing. You simply get the highest bar, in other words, the value with the highest frequency density, and you simply make a mark there, make a mark here, join the two using a ruler, a mark here, join the two using a ruler, and then where this one here points vertically, this will give us our mod. And that is it. That's how we get the mod, using the histogram and then calculations. Thank you for listening. You can attempt the exercise or the quiz in the next part. See you.